Before starting competition level questions, let us see few more important points. First point is temperature of the container rises in case of exothermic reactions due to the liberation of heat energy. Second point is all displacement reactions are exothermic reactions. Third point is reactivity series of metals is this. We will see few questions based on the reactivity series. Fourth point, oxidizing agent reduces while reducing agent oxidizes in a chemical reaction. For example, in this chemical reaction, hydrogen gains oxygen to form H2O, so it oxidizes. At the same time, it works as a reducing agent for CuO, which loses oxygen to form Cu. Similar way, CuO, which reduces to Cu after losing oxygen, works as oxidizing agent for H2, which gains oxygen to form H2O. Now let us see some named reactions. First one is neutralization reaction. When an acid reacts with a base, it forms salt and water. This type of reaction is called neutralization reaction. For example, HCl plus NaOH makes NaCl plus H2O. Second one is combustion reaction. A chemical reaction in which a fuel undergoes oxidation resulting in the release of heat energy is called a combustion reaction. For example, burning of natural gas CH4 plus 2O2 makes CO2 plus 2H2O plus heat. Third one is esterification reaction. When a primary alcohol is treated with a carboxylic acid in the presence of sulfuric acid, a sweet smelling compound called ester is formed. This chemical reaction is known as an esterification reaction. C2H5OH plus CH3COH in presence of sulfuric acid makes CH3COO C2H5 plus H2O. The main identification of this type of reaction is an alcohol will react with an acid. Now let us see some NCERT exemplar questions. First question is, the following reaction is an example of a displacement reaction, combination reaction, redox reaction, neutralization reaction. And the reaction is 4NH3 plus 5O2 makes 4NO plus 6H2O. Now let us analyze. In this reaction, O2 is displacing hydrogen from NH3 to make NO. So this is displacement reaction. The second option is combination reaction. It cannot be combination reaction because in combination reactions, two or more reactants make a single product. Here two products are getting made, so this cannot be combination reaction. Third one is redox reaction. Let us see. NH3 loses hydrogen to form NO, so it is getting oxidized. At the same time, O2 is gaining hydrogen to make H2O, means it is getting reduced. So this is redox reaction. Fourth one is neutralization reaction. It cannot be neutralization reaction because in neutralization reaction, one acid reacts with one base to form salt and water. That is not the case here. So the correct options are 1 and 3. And the correct option is C, which says 1 and 3 are correct statements. Second question, which of the following statements about the given reaction are correct? The reaction is 3Fe plus 4H2O makes Fe3O4 plus 4H2. First statement is iron metal is getting oxidized. Second is water is getting reduced. Third is water is acting as reducing agent. Fourth is water is acting as oxidizing agent. Let us see. Fe is gaining oxygen to form Fe3O4. So it is getting oxidized. First statement is correct. H2O is losing oxygen to form H2. So it is getting reduced. So the second statement is also correct. Third statement is water is acting as reducing agent. Let us see. H2O is losing oxygen to form H2. So it works as oxidizing agent for iron. So third statement is wrong. Fourth statement is water is acting as oxidizing agent. That is correct. So the correct statements are first, second and fourth. And the option C, which says first, second and fourth are correct statement, is the right choice. Third question, which of the following are exothermic processes? First reaction is reaction of water with quicklime. That means CaO plus H2O makes CaOH twice plus heat, means this is exothermic reaction. Second one is dilution of an acid. When water is mixed in concentrated acid, heat energy is liberated. So this also is exothermic reaction. Third one is evaporation of water. It is endothermic reaction because water absorbs heat to evaporate. So this is endothermic reaction. Fourth one is sublimation of camphor. Camphor absorbs heat to sublimate. So this also is endothermic reaction. So the correct options are option 1 and 2, and the correct choice is A, which says 1 and 2 are correct. Fourth question, a dilute ferrous sulfate solution was gradually added to the beaker containing acidified permanganate solution. The light purple color of the solution fades and finally disappears. Which of the following is the correct explanation for the observation? So these are the 4 explanations given. The balanced chemical equation for this reaction is given as 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4 gives 5 Fe2SO4 thrice plus K2SO4 plus 2 MnSO4 plus 8 H2O. Potassium permanganate KMnO4 reacts with ferrous sulfate FeSO4 to make ferric sulfate Fe2SO4 thrice. The number of oxygen atoms in ferrous sulfate are 10 into 4, that is 40. The number of oxygen atoms in ferric sulfate are 4 into 3, that is 12 into 5, that is 60. So ferrous sulfate is gaining 20 atoms of oxygen to make ferric sulfate. So it is getting oxidized, and the oxidizing agent is KMnO4, that is potassium permanganate. So the option A that says KMnO4 is an oxidizing agent, it oxidizes FeSO4 is correct. Fifth question, in the double displacement reaction between aqueous potassium iodide and aqueous lead nitrate, a yellow precipitate of lead iodide is formed. While performing the activity, if lead nitrate is not available, which of the following can be used in place of lead nitrate? So these 4 options are given. So this is the chemical equation. PbNO3 twice plus 2Ki makes PbI2 plus 2KNO3. We know that PbNO3 twice is made of Pb++ and NO3- ions. Lead nitrate's replacement should look very similar to it. Let us see the options given. First one is lead sulfate. Lead sulfate is written as PbSO4. It is made of Pb++ and SO4- ions. So it is not similar to Pb++ and NO3-. So it is not the correct option. Second option is lead acetate. Lead acetate is written as PbCH3COO twice. It is made of Pb++ and CH3COO- ions, which is very similar to Pb++ and NO3- ions. So this is the correct option. Let us see the other options as well. Option C is ammonium nitrate, means it is written as NH4NO3. It is made of NH4+ and NO3- ions. So this is not the correct option. Last option is potassium sulfate. It is written as K2SO4. It is made of K+ and SO4- ions. It is not similar to Pb++ and NO3-. So this also is not the correct option. So the correct option we have found is option B, lead acetate. Now let us see short answer questions. Question number 6. Write the balanced chemical equations for the following reactions and identify the type of reaction in each case. First one is nitrogen gas is treated with hydrogen gas in the presence of a catalyst at 773 Kelvin to form ammonia gas. The balanced chemical equation is N2 plus 3H2 in presence of catalyst and at 773 Kelvin makes 2NH3, and the type of reaction is combination reaction. Second reaction is sodium hydroxide solution is treated with acetic acid to form sodium acetate and water. Balanced chemical equation is given as NaOH aqueous plus CH3COOH aqueous gives CH3CONA aqueous plus H2O liquid. This is double displacement reaction. As we know, NaOH is made of Na plus and OH minus ions. CH3COH is made of CH3COO minus and H plus ions. Na plus combines with CH3COO minus ion to make CH3COONA, and H plus combines with OH minus to make H2O. So this is double displacement reaction. This is also neutralization reaction. As we know, in neutralization reaction, one acid reacts with one base to make salt and water, and this is the case here. Acid CH3COH reacts with base NaOH to make salt CH3CONA plus water H2O. Third reaction, ethanol is bound with ethanoic acid to form ethyl acetate in the presence of concentrated H2SO4. Balanced chemical equation is given as ethanol, that is ethyl alcohol C2H5OH aqueous plus ethanoic acid, that is CH3COH aqueous in presence of concentrated H2SO4 represented as H plus gives CH3COO C2H5 aqueous plus H2O liquid. This is double displacement reaction. As you can see, C2H5OH is made of C2H5 plus and OH minus. CH3COH is made of CH3COO minus and H plus. C2H5 plus combines with CH3COO minus to make CH3COO C2H5, and H plus combines with OH minus to make H2O. So this is double displacement reaction. This is also esterification reaction. As you can notice, one alcohol C2H5OH reacts with one acid CH3COH to make ester CH3COO C2H5 and water. Last reaction is ethene is burned in the presence of oxygen to form carbon dioxide, water, and releases heat and light. Balanced chemical equation is given as C2H4 plus 3O2 gives 2CO2 plus 2H2O plus heat and light. This is redox reaction as well as combustion reaction. Let us see how. C2H4 loses hydrogen to form CO2, so it is getting oxidized. O2 gains hydrogen to form H2O, so this is reduced. So this is redox reaction. Since C2H4 is combining with oxygen to form CO2, water, heat and light, so it is combustion reaction. Seventh question. Complete the missing components or variables given as X and Y in the following reactions. First reaction is PbNO3 twice aqueous plus 2Ki aqueous makes PbI2X plus 2KNO3Y. We know that PbI2 is solid, so in place of X it will be written as S. And we know that KNO3 is aqueous, so in place of Y, AQ will be written. Second reaction, CuS plus 2AgNO3 aqueous makes CuNO3 twice aqueous plus XS. Balanced chemical equation is given as CuS plus 2AgNO3 aqueous makes CuNO3 twice aqueous plus 2AgS. So in place of X, 2Ag will be written. Third reaction is ZnS plus H2SO4 aqueous makes ZnSO4 X plus H2Y. Balanced chemical equation is given as ZnS plus H2SO4 aqueous makes ZnSO4 aqueous plus H2 gas. So in place of X, AQ will be written. In place of Y, G will be written. Last reaction, CaCO3S, X above the arrow, CaOS plus CO2G. We know that when CaCO3 is heated, makes CaO solid plus CO2 gas. So in place of X, heat will be written. Eighth question, identify the reducing agent in the following reactions. In these reactions, we need to identify which reactant is getting oxidized. That reactant will work as reducing agent for other reactant. First equation is 4NH3 plus 5O2 makes 4NO plus 6H2O. Here NH3 is losing hydrogen to form NO. That means it is getting oxidized. So it will work as reducing agent for oxygen. So NH3 works as reducing agent. Second equation is H2O plus F2 makes HF plus HOF. Here H2O is losing hydrogen to form HOF. so it is getting oxidized. It will work as a reducing agent for F2. Third equation is Fe2O3 plus 3CO makes 2Fe plus 3CO2. Here CO is getting oxygen to make CO2, so it is getting oxidized. It will work as a reducing agent for Fe2O3. Last equation is 2H2 plus O2 makes 2H2O. Here H2 is gaining oxygen to make H2O, so it is getting oxidized. It will work as a reducing agent for O2. Ninth question, why do fireflies glow at night? Answer is, fireflies secrete luciferase enzyme. When the oxygen combines with calcium, ATP and luciferin in the presence of luciferase, a new substance named oxyluciferin is formed along with the evolution of energy in the form of light. Now let us see long answer questions. Question number 10. On heating blue colored powder of copper nitrate in a boiling tube, copper oxide, which is black in color, oxygen gas and a brown gas X is formed. First part, write a balanced chemical equation of the reaction. So the balanced chemical reaction is 2CuNO3 twice solid when heated makes 2CuO solid plus 4NO2 gas plus O2 gas. Second part is identify the brown gas X evolved. Brown gas is nitrogen dioxide NO2. Third part is identify the type of reaction. This is decomposition reaction as a single substance is getting decomposed to two or more products. Last part is what could be the pH range of the aqueous solution of the gas X. When NO2 reacts with water, it makes HNO2 and HNO3, two acids. Balanced chemical equation is 2NO2 plus H2O makes HNO2 plus HNO3. Since the product is acidic, so pH range will be less than 7. Question number 11. Give the characteristic tests for the following gases: CO2, SO2, O2 and H2. First one is carbon dioxide. When carbon dioxide gas is passed into lime water, it turns lime water milky due to the formation of insoluble calcium carbonate, and the reaction is given by CaOH twice plus CO2 makes CaCO3 plus H2O. Second one is sulfur dioxide. Sulfur dioxide gas is a strong reducing agent. When passed through acidic potassium permanganate solution, which is purple in color, turns it colorless. Reaction is given as 2KMnO4 plus 5SO2 plus 2H2O makes K2SO4 plus 2MnSO4 plus 2H2SO4. Third one is oxygen. The evolution of oxygen gas during a reaction can be confirmed by bringing a burning candle near the mouth of the test tube containing the reaction mixture. The intensity of the flame increases because oxygen supports burning. Hydrogen gas. Hydrogen gas burns with a pop sound when a burning candle is brought near it. This happens because of the combustion of hydrogen gas. Question number 12. You are provided with two containers made of copper and aluminium. You are also provided with solutions of dilute HCl, dilute HNO3, ZnCl2 and H2O. In which of the above containers these solutions can be kept? First we will see reaction between copper and these compounds. Then we will see reaction between aluminium and these compounds. Copper does not react with dilute HCl. So dilute HCl can be stored in a copper container. Copper reacts with dilute HNO3. So dilute HNO3 cannot be stored in a copper container. Reaction takes place like this. 3Cu plus 8HNO3 makes 3CuNO3 twice plus 2NO plus 4H2O. Copper is less reactive than zinc. It cannot displace zinc from zinc chloride solution. So zinc chloride can be stored in a copper container. Copper does not react with water, so water can be stored in a copper container. Let us see the reactivity of aluminium with these compounds. Aluminium reacts with dilute hydrochloric acid to form its salt. So dilute HCl cannot be stored in an aluminium container. Reaction takes place like this. 2Al plus 6HCl makes 2AlCl3 plus 3H2. Aluminium reacts with HNO3 to form a passive layer of aluminium oxide, which protects aluminium from further oxidation, so dilute HNO3 can be stored in an aluminium container. Aluminium is more reactive than zinc. It displaces zinc from zinc chloride. So dilute zinc chloride cannot be stored in aluminium container. The reaction takes place like this. 2Al plus 3ZnCl2 makes 2AlCl3 plus 3Zn. Aluminium does not react with cold water. Aluminium reacts with steam to form a passive layer of aluminium oxide which protects it from further oxidation. So water can be stored in aluminium container. Now let us see few Olympiad questions. I have taken these questions from NSO Olympiad workbook by MTG Learning. Question number 13. 4 students P, Q, R and S noted the initial color of the solutions kept in beakers 1, 2, 3 and 4. After inserting zinc rods in each solution and leaving them undisturbed for 2 hours, the color of each solution was again noted in the form of table given below. Now based on the reaction between zinc and aluminum sulfate, zinc and zinc sulfate, zinc and iron sulfate and zinc and copper sulfate, 4 students observed the color change and noted down as in this table. Now we have to reply which student noted the color change in all the 4 beakers correctly. Let us see chemical reactions taking place in all the 4 beakers one by one. In first beaker, zinc is supposed to react with aluminum sulfate. Zinc is less reactive than aluminum. It cannot displace aluminium from aluminum sulfate solution. So no reaction will take place, means there will not be any change in color of the solution. In second beaker, zinc is supposed to react with zinc sulfate. So zinc cannot displace itself, or even if it displaces, no new product is formed. So no reaction in this case also. So no change in the color of the solution. In third beaker, zinc is supposed to react with iron sulfate. Zinc is more reactive than iron as per reactivity series. So zinc will replace iron from iron sulfate solution and make zinc sulfate. So there will be change in color of the solution. In fourth beaker, zinc is more reactive than copper. So zinc will replace copper from copper sulfate solution and make zinc sulfate. So again change in color of the solution in fourth beaker. So let us see the table once again. Let us see observation of student P. In first beaker, he doesn't see any change in color. That is correct. In second beaker, he doesn't see any change in color. That is correct. In third beaker, from light green to colorless. That is also correct. In fourth beaker, from blue to colorless. That is also correct. Means student P got all the observations correct. So option A is correct. Question number 14. Lead nitrate crystals are burned in air. Which of the following observations are correct? First one is a double displacement reaction takes place. Second one is brown fumes of NO2 are evolved. Third one is black residue is left behind in the test tube. Let us write the chemical equation first. Chemical equation is 2PbNO3 twice decomposes to 2PbO plus 4NO2 plus O2. So the first statement that says a double displacement reaction takes place is wrong. This is decomposition reaction, not double displacement reaction. Second is brown fumes of NO2 are evolved. This is right. Third is black residue is left behind in the test tube. It is not the black residue, it is yellow residue or PbO that is left behind in the test tube. So statement 3 is also incorrect. Only statement 2 is correct. Option D that says only statement 2 is correct is the right choice. Last question. Rupali, a class 10 student, has set up the apparatus as shown in the figures. In first beaker, 20 ml of water plus K2SO4 is there. In second beaker, 20 ml of water plus NH4NO3 is there. In third beaker, 20 ml of water plus anhydrous CuSO4 is there. In fourth beaker, 20 ml of CuSO4 plus zinc granules are there. Which of the following observations is correct? Observation A. Temperature of beakers 1, 2 and 3 will be raised as dissolution of salts is an exothermic process. Observation B. Temperature of beakers 1, 3 and 4 will be raised while temperature of beaker 2 will fall. Observation C. Temperature will rise only in beaker 4 as redox reactions are exothermic. And option D. None of these. Let us find out. In beaker 1, K2SO4 dissolves rapidly in water, so it is exothermic reaction, means temperature of this beaker will rise. In beaker 2, NH4NO3 absorbs energy from the water, it is endothermic reaction, so temperature of beaker 2 will fall. In beaker 3, copper sulfate will react with water and water molecules will be attached to it and heat will be liberated. So it is exothermic reaction, means beaker 3's temperature will rise. In beaker 4, zinc will react with copper sulfate to make zinc sulfate and copper plus heat will be liberated. So it is exothermic reaction, means beaker 4's temperature will also rise. So temperature of beaker 1, 3 and 4 will rise whereas beaker 2's temperature will fall. So option B is the correct one. You may practice more competition level questions. Links are given in the description box below. If you want to ask questions, you may join my Discord server. If you have not yet subscribed my YouTube channel, please do so.